How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at practice problems for 21.2 patterns of nuclear stability. So number one, at about how many protons or neutrons does the 1-to-1 ratio of protons to neutron ratio for stability start to break down? And it's at about 20. So once you get to about 20 protons, it's going to start shifting away from this 1-to-1 ratio. All right. Number two. What is the last stable number of protons a nucleus can have? And it's 83. Anything over that is always going to be unstable. It's going to be radioactive if it's that big. Number three, most stable nuclei have an even number of neutrons and an even number of protons, right? There's something about pairing up, just like when you looked at electrons. There's something about when they come in pairs that adds to the stability. Or rubidium can form krypton through what nuclear reaction? Now I had one answer in mind, but I guess there's two possible answers. So rubidium, we got Rb as a charge of 37, and the mass isn't really all that important because it can go through some sort of process where it's going to make krypton, which has a charge of 36. So we need some process that's going to bring the charge of the product down by one. One possible way that could happen is by giving off a positron, right? Because that still balances out. Or another way, well, let's see, Rb 37, and then krypton 36. There's this process called electron capture, where basically you have an electron or a beta particle that gets captured by the nucleus, which would also result in bringing the atomic charge down by one, making krypton. Oh, that's it. Hope you found it helpful. See you in class. Okay, bye.